Before I introduce our speakers, I want to introduce myself. I'm Zach Semke. I'm director of Passivhaus Accelerator, and today I'll play the role of Q&A concierge. ROCKWOOL North America. ROCKWOOL is a leading manufacturer of stone wool insulation. They've been doing this for over 80 years. They offer a full range of high-performing and sustainable insulation products for passivhaus construction. Stonewool, as you may know, delivers multiple co-benefits as well as an insulation solution, including fire resistance, superior thermal performance, acoustic control, water resistance, and lots more. Our presenters are Mahnaz Nikbakht, who is architectural manager of Eastern Canada for ROCKWOOL, and Robert Blount, who is architectural manager for New England. So with that, Mahnaz and Robert, please take it away.
Hello, everyone. So let me just share my screen. Is everyone okay seeing that?
Yes, looks good.
All right, well, thank you everyone for being there. We as a team, Robert and I, are representing North America. Well, ROCKWOOL North America. For me, I'm based in Montreal, so hello from Montreal. And Robert is in the US and near Boston. So we want to talk about Stonewool solutions for Passivhaus at the Passivhaus Accelerator Component Spotlight. I'm really excited to be here. Quick overview. We're going to do the intro on who we are and what our mission is. We want to speak about the specifics of our material, which is Stonewool. Robert will speak about different projects that should be of interest to you, Passivhaus projects, and then we'll speak about, there's going to be an overlap. We're going to speak about the products and what services we offer to you. So let's get started. Let me just move this away. Okay, so ROCKWOOL is a global company with its origins in Denmark. We have 5 brands. ROCKWOOL being the one that you probably know best for the building insulation. Rockfon is our, here we are, Rockfon is our acoustic ceiling solution. Rock Panel is not available here yet. It's an exterior cladding solution for buildings. Then we have Lapinus. So here we are. It's a specialty application for noise and vibration control, and Grodan is quite a different thing. It's used as a substrate in horticultural industry. And all of these products are made predominantly of basalt rock. So, as I said, we are representing ROCKWOOL North America. And so I just want to show you where our material is being manufactured. So, we have our Milton plant in Ontario, which is not too far from where I am. And we have another plant on the west, in the west, which is in British Columbia, Grand Forks. We have a plant in Mississippi, close to Memphis, actually. And we are very happy to announce that in July of this year, we opened our 4th plant in Ranson, West Virginia. So, I'm just going to speak a little bit about delivery issues. We are facing the highest demands ever, and all of our plants and all of our manufacturing teams are working like crazy to make as much ROCKWOOL as possible. We're constantly adapting our processes to have better output. In fact, all of our manufacturing sites have the highest output they've ever had. So let's say we are creating as much as we can. We're at the top of our capabilities. We're expecting a bit more to come from the new plant. But just to say, we're really working very hard to make sure that material gets out of our plants to you. So let's talk a little bit more about the energy efficiency, energy consumption. We all understand that it's cities and buildings that contribute to the global energy consumption, or contribute most, and to carbon emissions. And this is a reason why we're here. ROCKWOOL is part of this solution by improving energy efficiency with our insulation materials. So we've aligned ourselves with several sustainability focused initiatives to make a change. So as a global manufacturing company, we really want to play a role in making those changes. And we've committed to the United Nations Sustainable Design Goals. These are 17 different classes or goals, and we've committed to 10 of those. What we're doing is either we're minimizing the product impact, we're maximizing the impact that the product can have on these goals, or we're minimizing the operational impacts that we have. So as an example, this here comes from our sustainability report that you can download from our webpage. When we're looking at goal number 13, climate action, what we're doing is we're committing to reducing CO2 emissions from our Stonewool production facilities by 20% by 2030. Or if we talk about affordable and clean energy as one of the goals, we are committing to improving the energy consumption of our buildings. So what we can see here on the right-hand side is our office in Gladbeck, which is also one of our, apart from the Denmark ones, one of our oldest sites, Gladbeck in Germany, and it's going through a deep renovation where we're looking at improving energy efficiency by 80%. So that's aligned with the UN sustainability goals. We're also committed to the Science-Based Target Initiative. This is an initiative that drives climate action in the private sector so that companies get the support and also the control and the review to set science-based emission reduction targets. So we're in our third year now. We started in 2019. And we believe that the private sector definitely plays a big role in reducing greenhouse gases. So our plan is to reduce by a third the greenhouse gas emissions within 15 years. We're also participating in the LP50 material pledge. So we're working on having more transparency of materials. And finally, we've been looking at our products and the impact that they have. And we are a net carbon negative company because when we look at the lifetime, when we look at the material, we took 2019 as a baseline. So if we take all of the material we sold in 2019, over its lifetime, it's going to save 100 times the carbon that was emitted in its production. So we're really trying to improve the impact that our materials have. And finally, Rockwool and Passivhaus. This is a long, it's an old story. It's going on for quite a while. We're involved with a number of Passivhaus groups, associations. So we are the sponsor here of the Passivhaus Accelerator. Me personally, I'm the chair of Bâtiment Passif Québec, where we're trying to do everything in French language. Our colleague Todd Kimmel in New York is on the board of the New York Passivhaus Association. We have members in the Passivhaus California group. We're supporting the Passivhaus network. So we're really trying to make everything move in the right direction. So let's talk about properties and the environmental benefits of our materials. So yes, this is a rock, a basalt rock. I'm just showing this because the material we use, stone, is powerful, is a strong and resilient material. And our name Rockwool is there for a reason, because our material is predominantly made of rock. So that brings me to this point of terminology. There is the term mineral fiber, mineral wool, stone wool, slag wool. So I just want to clarify what's the difference, what is what. So if we start with mineral fiber, okay, that's a generic term for anything that is a fibrous inorganic substance. And we classify these into three groups: fiberglass, So fiberglass is a material consisting of glass fibers, and it's being used in many different applications and products. And the one that you probably know a lot is either maybe for windows, or it could be the pink insulation material that you know. Then there is the term mineral wool, and that might be a common term, but you might not necessarily be familiar with the subcategories, which are stone wool and slag wool. So mineral wool is made out of stone and slag. Stone wool then, on the other hand, is predominantly made from stone, while slag wool is predominantly made from slag, which is a byproduct of iron ore when you're producing steel. And then there is a third category, which is the refractory ceramic fibers. And we don't really come across this too much in the built environment. This is for specialty applications in high temperatures or industrial applications. So now that we've cleared what is mineral fiber and what is mineral wool, we do stone wool. Yeah, there is a little bit of a difference between stone wool and slag wool as with regards to the performance, as stone wool definitely has a higher melting point and therefore has a higher fire resistance. So how is it made? Stone wool is made pretty much like cotton candy. It's kind of weird to imagine, but what we do, instead of taking sugar, we take basalt rock and steel slag, and we melt it at high temperatures. And then well, I don't, but in our plants, this melted mixture is poured over spinning wheels, and then these spinning wheels make fibers out of it, and these fibers are collected on some sort of a conveyor belt. And then depending on, you know, the speed and so on, the throughput of the machines, you can make higher or lower density materials. So I have to say, I'm waiting for me to be able to go visit the plant, you know, because I started with ROCKWOOL since 10 months, so within the COVID period. So I'm very eager to actually see this process myself. So this, there is a, yeah. So what's interesting with stone wool insulation is that it has a lot of versatility. What do I mean by that? So this here represents densities. So on the left we have, sorry, this here represents densities. On the left we have low density, on the right we have high density. And we typically know mineral fiber materials for, or fiberglass for low density materials. And when we're looking at high density or more rigid materials, we typically know foam materials. And the interesting thing with stone wool is that you can actually make all of it. So you can have your batt insulation, which is a low density material, as you can see here. Maybe this kind of gives us a better idea. So we have a low density, this is comfort batt material that is kind of soft. And on the right-hand side, you have a board. So we can also transform this stone fiber into rigid boards with high or very high or extremely high densities, and to use it as a panel. Okay, so just to finish up, to summarize, the benefits of using stone wool are numerous. Oops, sorry. So non-combustible, I think that is clear to everybody. It's a key property to our material, which differentiates it a lot. But another point is, what I was trying to show with that stone photo is that it's kind of just a stone. It doesn't do anything. It's thermally stable. It doesn't move. It doesn't change. It doesn't, you know, it has a R value that is stable over time. And at the same time, it's also stable dimensionally. It's a water repellent product, so it's naturally hydrophobic. It's a vapor permeable product, so depends on which school you're from, but if you're into the vapor permeable structure, then you want to have a material on the outside of your building or on the inside that allows humidity to escape and humidity to dry out, because it gives you an extra security. And then mineral wool being more on the heavy side, it definitely is a great addition to create a higher acoustic performance for your building. And I think with that, I'm going to hand this over to Robert.
Thank you, Mahnaz. Give me a second here to switch screens. Does everybody can see that okay?
Yeah, looks good.
Yeah.
Very good. My name is Robert Blount. I'm the architectural manager for ROCKWOOL here in, I sit about 30 miles north of Boston in Newbury, Massachusetts. I've been with ROCKWOOL about 2.5 years. I've been in the building enclosure world about 20. I spent a good chunk of that time as an exterior enclosure consultant, also worked on the fabrication and installation side, mostly doing design assist with architects, trying to come up with a better and more efficient way to put together wall assemblies. I'm going to kill my camera because I live in the middle of nowhere and bandwidth is at a premium here, so I want to make sure that everything goes as smoothly as possible. So Mahnaz has done all the heavy lifting, if you will, explaining the technical aspects of our product. I'm going to go through a few projects where we've been used, all Passivhaus and Passivhaus level projects. The one that I will start with is perhaps one that you're familiar with, because I know I've seen this in the somewhere in the history of the accelerator. It's an interesting project from Scott Henson Architects. Jane Sanders specifically was a project lead. So this is a project in New York City where, as many of you are probably familiar, they've set new emission targets for buildings. Their CMA legislation, Local Law 97, has set some step targets moving towards net zero with marks in 2024, 2030, and 2050. The eventual goal there moving to near net zero or net zero. We're all aware that buildings are amongst the worst carbon emitters, especially in urban areas. So a lot of the large building owners in New York City are realizing that they've got some big changes to make, and they really have to take a close look at what's going on with their buildings. In this particular case, and this is prevalent in the city, the one occupant in this building, which is a pre-war construct, who was actually the head of the co-op, wanted to do Passivhaus retrofit on his unit. So it wasn't a deep energy retrofit for the whole building, but specifically looking at a single unit where that owner wanted to meet Passivhaus energy retrofit levels, of course, while maintaining the integrity and historic nature of the building. It is a landmark building. They wanted to, of course, improve thermal comfort as well as acoustic performance. Historically, these types of buildings weren't fantastic when it comes to sound transmission between units. So not only looking to insulate the floor and the ceiling from a thermal perspective, but also an acoustic perspective, of course, while meeting Passivhaus standards for air tightness. So there's also an understanding with historic buildings that there's a sensitivity to moisture content and the overall durability of the solution. So Stonewool plays pretty well into that in terms of permeability. So there was also a concern for being able to deconstruct materials if they were in a position where they had to make further maintenance from the outside. Local Law 11 still applies in New York City, so sometimes they're digging into the outsides of these historic structures as well. So we can see on the left a kind of a start to finish series of images courtesy of Jane Sanders. So starting there at the top left, the original construction, we can see those through wall penetrations with the HVAC system, and everything was basically gutted from inside out. An air barrier was applied to the brick air and water barrier, then followed up by our semi-rigid cavity rock, and then behind that also a smart barrier from Intello, and then LGMF studs beyond that to allow for the service cavity. So going from inside to outside, this is a Stonewool Tower in Hamilton, Ontario, Passivhaus retrofit. So completed in 2020. The end product was an R38 effective R value. So the solution here was to add insulation both interior and exterior. On the exterior, 1 6-inch thick layer of Stonewool. So this is a relatively new concept, a Stonewool ethos. Initially with this, this was kind of a pilot project for us. We used our Durock product, which is typically used in more industrial applications, but the product that we now have incorporated in Stonewool ethos solutions is called Front Rock. It's used by master builders who were formerly BASF. So there's 6 inches of that on the outside, along with 2 inches of foil-faced curtain rock on the interior of the concrete structure, and then leaving the steel studs empty again for a service cavity. So the goal here, of course, was to create an ultra-low energy retrofit, meeting Passivhaus and interfit standards. So that solution was, as I said before, both interior and exterior. The interior, a more typical approach, with a couple of inches of insulation and steel studs, and then on the exterior, the ethos solution. So they were looking to meet Passivhaus standards for a number of reasons here. Pretty lofty goal, looking to reduce overall greenhouse gas emissions by 90%. This is an interesting project in my mind as well, because one of the big targets here was also for passive survivability. This is a kind of an at-risk community building, low-income and senior housing building, where I think most of us, if things go sideways with a climate event, have the opportunity to take off, go check into a hotel, see friends, go see relatives. But oftentimes in these types of scenarios, it's very difficult to initiate some kind of mass evacuation. So the other big goal was to be able to shelter folks in place in the building, and the end result here is that through modeling, we're looking at the ability for folks to stay in place for 2 days with no power or heat, going down to, as this is in Toronto, going down to -30°C, and for 4 days in the event of a hot climate event, so approaching 100 degrees F. This is a project that, judging from some of the familiar faces and names that I see on the call today, that I'm sure everybody's seen, Handel's house at Cornell Tech. Really pretty inspiring stuff here. The house at Cornell Tech shows what's possible in targeting New York's pretty ambitious environmental goals, right? Standing 26 stories. At the time that it was built, this residential facility for students and staff and faculty was the largest and highest building ever to be built to the Passivhaus standard. They used a unitized panel approach. So using our semi-rigid cavity rock along with the clip and rail system in building mega panels. So really trying to speed up the process of construction as well. The architects used our materials exclusively. So at a 280 millimeter thickness cavity rock on the outside, using our rock board material on the inside, as well as our AFB, which is acoustic fire bat, for both acoustic and fire resiliency in the partition walls. It's estimated that the house will save 882 tons of carbon emissions per year. So that is the equivalent of planting 5,300 new trees. So as New York leads the way here south of the border in lightening its environmental footprint, we here in Massachusetts, specifically in Boston, are actually following close behind with new legislation that's been passed just in the past week. Another example of passive house build. This one's kind of near and dear to me because it's across the street from where I used to live in Hoboken, New Jersey. It was a market rate multifamily passive house build, 8 inches of cavity rock with Cascadia clip and a fiber cement panel system. At the time that this was being built, they were really using passive house as a selling point, which is, you know, I spent 10 years in New York City. Feels like a lifetime ago, but you know, there was no, apart from LEED, you know, there wasn't, it didn't seem prevalent that folks were using sustainability as a selling point, but this project sold out long before it was completed. Hannock Corona senior residence in Corona, Queens, New York. Think architecture with CPHC services from Duncan Architects. So this project provides 67 units of affordable housing to seniors. So folks over 62 that are earning between 40 and 60% of their median income in New York City. So that includes 21 apartments set aside for formerly unhoused folks. And it's one of the largest low-income senior housing developments in the nation to be passive house certified. Clayton Heights Community Center in Surrey, BC. So this, the Clayton Community Center combines 4 aspects of Surrey's community services. It's a recreation center, a library, an arts destination, and also incorporates some of the parks facility offices. So a very seamlessly integrated facility, opened up its doors in 2021 and is the first of its kind to achieve passive house in North America. And it is also Canada's largest, at the time, largest passive house facility to date. So a 7,000 square meter glulam structure insulated with our cavity rock. And this was HCMA and Morrison Hirschfield as the envelope engineers. Skeena residence at the University of British Columbia, really setting new standards for the university with a new student residence on the Okanagan campus. This residence houses 220 students in a kind of typical dorm design, side-by-side singles. The structure was kept pretty simple. It only has 2 openings, entry and exit doors, to maximize tightness, and this was completed in 2020. I'm going to talk a little bit about our products. So we've seen a couple of projects. So I'm going to talk a little bit about which products work in which applications. So Cavity Rock is our semi-rigid board, and you can see if you look closely in the photograph that there's really 2 layers to the product. It's a dual density product, so the out-facing layer is about 6 pounds per cubic foot. And then the inner layer is closer to 4 pounds per cubic foot. And the idea here is that this product is ideally used in conjunction with clip and rail systems with pull-through girts, but that softer backside of the material allows for it to more easily conform around all that hardware. Also does a good job of sucking up any irregularities in the surface that it's being applied to. So when we avoid all those gaps and spaces, we also do a really good job of hopefully preventing convective looping. And we see in studies that oftentimes in typical builds, convective looping is good for up to 20% loss in overall efficiency in terms of R value. We also have that same product, Cavity Rock, with a black facer. So the black facer is simply a glass fiber mat. It doesn't affect the combustibility of the material. Having lived on the contractor installer side of the world, I joined Rockwool 2.5 years ago, and this product came back into play for us not long after it. And I just finished 110,000 square foot plus open joint rain screen system project and started looking at the numbers on what what are the savings for skipping this step, right, of applying a loose scrim facer. And depending on what your labor costs are and where you sit in North America, it's somewhere between $1 to $2 a square foot. And so I looked, hindsight 2020, looked back at sadly at what could have been saved there. But to give you an idea, I think we're all pretty familiar with what the rain screen application is for an open joint system. So typically if you're not into seeing the beautiful brown material, that black facer allows you to skip a step. We also have recommendations for tapes that you can use on the seams and make that approach for an open joint rain screen system easier. Comfort board is 80 and 110 are our rigid boards. So these would be used in a screw through application. Really we're working tension, compression, and friction against each other with these vertical girts and relatively frequent long screws that go through the insulation. So really those are the only thermal bridges. This particular approach is good for, depending on your loading, is good for generally 15 pounds per square foot capacity. The 80 is typically seen more in residential applications or lighter, lighter cladding scenarios, and the 110 for heavier cladding scenarios. Don't want to leave out comfort bat. So in instances where we can't get everything that we need by doing continuous insulation on the outside, comfort bat is the material that we use in the service cavity if you're not leaving that open for, and especially in urban environments where we know we've got a lot line and a setback and a client that wants every bit of programming space they can get out of that floor plate. Sometimes we're in the position where we're insulating both inside and outside the weather resistant barrier. And I'll talk a little bit more about that when it comes to hydrothermal modeling and some rules of thumb. We also have materials for roofing. The comfort board 80 or 110 can be used on pitched assemblies. That is typically more of a residential approach. Commercially, especially if you're working with certain types of projects that require, in the US, it might be FM global, but in Canada, if there's big wind uplift requirements, the Top Rock DD is what we typically recommend for low slope applications. It comes, as you see it here, in a dual density format. It also comes with a facer for hot applied and fully adhered systems. There's also accessories like cant strips for this type of detailing, and also can be fabricated to accommodate the tapered applications. The comfort board 80 and 110 can also both be used as below grade applications. Oftentimes I recommend that a dimple mat facer is used depending on your backfilling operations. Whoops, sorry. Just for protective, for belt and suspenders protective measures, but it is not necessarily, it's not crucial to do so. Also, these, I think everybody's probably used to seeing these board materials in a 2x4 format. They can be obtained in up to 4x6 sheets. The consideration there is that because these materials are 8 and 11 pounds a square foot respectively, at some point there's kind of a tipping point with how big you want that sheet to be and the weight and the manageability of it. Underslab is also an option for the use of comfort board, depending on the compressive needs of your slab or the weight that's going to be applied to your slab. But that is not atypical both in commercial and residential applications. This on the lower right here is our typical passive house detail for the project that we see here in the upper left. In terms of services and support, we do have a number of details that are parts of passive house certified wall systems, where we take into consideration structure, keeping continuity with all of our control layers, and what finishes are going to be applied to those. We have available our Passive House Solutions Guide, which gives you, I think, a good starting point for using Stonewool in a passive house approach. We also have a number of case studies, amongst them the house at Cornell Tech, that give you, let you see the material in action as we see more and more passive house happening. I keep flipping forward accidentally. But to that end, we also offer some building science support. So we have a team of folks that sit up in Toronto and Milton, and they provide a complementary suite of technical services that are also non-proprietary. So if you want to do comparative analysis on this material versus other materials and what your most likely paths of success are, they'll do R value calculations as they relate to your local code, 2D and 3D effective R values, overall U value analysis, WUFI and hygrothermal analysis. They'll do full building modeling if you're willing to provide that kind of time and information, as well as a newly added acoustic analysis for STC. As I said, I've only worked for ROCKWOOL for a couple of years now, and I use this service pretty frequently prior to coming here. It's very quick. They say a week turnaround, but it's usually a couple of days. And really, they're looking to help folks find the best material that's going to lead to a successful project. This is what these analyses look like. This is everything from our basic effective R values to WUFI and hygrothermal analysis, including wetting and drying cycles in different parts of the year. We also have a number of other resources that if you reach out, we can provide you with, including cladding attachment solutions and some pieces on vapor diffusion, as well as some more hands-on guides for builders, as well as application guides for all of our materials. And then, of course, there are a number of very knowledgeable folks that work with us as well. Mahnaz, we're lucky to have picked her up here in the time of COVID. Todd Kimmel, who I'm sure some of you know, who sits on the board of Passive House New York, and Alejandro Nieto, who sits also up in Milton as a technical manager, as well as myself here in New England. I'm actually working on my CPHC, so hopefully towards the beginning of the year, I'll be on that other slide. Pamela Sadler, who is our spec manager in California and also part of Passive House California, and Ryan Foster up in Canada, who is our spec manager for Central and Western Canada. And that is it for the presentation part of things. I would be more than happy to answer questions. I haven't even been watching the chat.
Well, there are lots of them. Robert and Mahnaz, thank you. Fantastic presentation, super interesting, and you've definitely generated lots of curiosity and questions here. So we're gonna dive into that. So in chat I posted the queue for questions, and the first person up is Kara Wall. Kara, can you ask your question?
Yes, is the rigid board Rockwool insulation available in the United States?
Yes, absolutely.
That was easy.
It's available on the commercial side through, we don't do direct distribution. We go through a number of second party distributors. And it's also available in box stores in select sizes, depending on your climate zone. So the higher up you are in the US, the more likely you are to find a thicker material, and it's in 2x4 boards.
So it's available in Michigan
Oh,
at
yeah.
a box store.
Yeah, and don't quote me on this because
Okay.
we've had some switches with where we're carried by the blue box versus the orange box, to make that clear without names. And also, if you have a good lumber and building materials supply in your area where where contractors are accessing material, it's also generally stocked in those places as well.
Okay, thank you.
Thank you, Kara. All right, next up is Joe Konopaki. Joe, are you still here? Let's see. I should have checked before I called your name
What's
here.
the question?
Oh yeah. So the question is, Joe is here. So the question is, what pest intrusion issues have been noted?
We don't know. There are none.
There has been a little bit of study and observation with this, and generally, if you're talking about termites or anything like that, picture chewing on rocks, even at the fibrous level, they generally aren't very interested. I have had anecdotally, I have had a couple of projects where folks were concerned with semi-open joint systems, like big, one that comes to mind in particular is the Shishougi boat plank job, where they have gaps in between, and there was concern about birds and other pest entry, and they haven't. This particular project has been in place now 4.5 years, and it's close to me, so I drive by it often. And as far as I know, in keeping tabs with folks there, it's not been a problem.
Great, thank you. Okay, next up is Huston Eubank.
Thanks. Actually, I have 2 questions, if I may, quick ones. The first one was I used a comfort board on when I renovated my own condo, similar to the first project you showed in Brooklyn. I was surprised. I was sleeping in the unit while I was renovating. I was surprised to smell the formaldehyde coming out of the board. How much formaldehyde is actually used, and can you assure me that it dissipates over time?
Okay, so, if I may answer to that, we actually use a phenol formaldehyde binder in our production, which is cured at very high temperatures in the process. And there are actually, I'm surprised that you say that you could smell it, because there are trace amounts of formaldehyde left in our material. We actually have a Green Guard Gold status for indoor quality for our materials. There is always some, sorry?
That's what I thought. So I was really surprised when I smelled it.
Yeah, me too.
But it dissipated within about 3 or 4 weeks.
I have had a comfort board installed on the inside in my house, and I did not notice anything.
Oh, well, you might need to reveal that in your product information. But the other question was, I was really surprised to see you putting the comfort board below grade and under a slab on grade. Mm-hmm. So you can basically use it the same as a foam insulation then.
Yes.
Yes.
That's wonderful. I didn't know that.
Yes, when you're using it as a drain board, for example, on this side, you do want to make sure you have a drainage at the bottom. You need to have a space for water to go. Obviously, water will not disappear by itself. It needs to be taken somewhere, but yes.
That's great. Thanks very much.
And there are some limitations there too. If you had a pitched water table where you know that you've got constant water up against the foundation, it may not be the ideal solution. But in most cases, good civil engineering is going to take that away from your building. And of course, there's some places where you just can't get away from it. And, we try to, keep everybody pointed in the right direction, and wouldn't recommend using it in places where it doesn't belong. And along those same lines, where people were, I think we're formerly using extruded polystyrene in that position, our carbon footprint is vastly lower than using XPS for that particular application.
I don't think those applications are well known among the professions. So you might want to promote those.
Oh, we do. That's
So they're really great. Thank you very much.
Yeah.
Thanks, Heston. Okay, next up is Kim Walton. Hey, Kim.
Hi there.
Hi.
Hello.
So I'm going to follow up with what we were just talking about before I asked my questions. So the below grade application and below slabs, and then below footings. I've really had a hard time with engineers accepting that position for comfort boards. So I just echo the fact that we need more education amongst civil engineers, especially about its capacity. But there's a concern that it can't take the loading, and then there's concern about it getting wet and staying wet and not being able to drain below grade.
Okay.
So I've had to do a lot of sales work in order to use the product below grade.
For both the comfort board or actually the top rock, we do publish the compressive strength that is given for these products. So, depending on the example that we showed was a single family home, so not a huge load. I really think it needs to be evaluated. Obviously, it's not the same as some other materials where you have an extremely high compressive resistance. It just needs to be analyzed. We have the testing for it, and it might be that in some places you cannot use it because it doesn't have sufficient compressive strength. It remains a fibrous material.
Right.
So
I guess what I'm saying is it might be helpful, for instance, if I could direct an engineer who is resistant to a helpline that would, so if that was something that was easy to access, then that would be helpful sometimes.
Where are you?
I'm in Canada, in Western Canada.
Okay, well, there would be Omar as a point of contact, or a Ryan Foster, who's somewhere here on the call.
Yeah.
I
So maybe if,
so.
So we can follow up. They can
could help.
Try and contact them and see if that's something that we can do, just for using that product instead of foams. So my question was about foams, about different rigid insulations. And I know that depending on the insulation, that the insulation value, the R value, depends on the temperature, the exterior temperature. So sometimes the insulation is more or less effective depending on the temperature. But do I understand that ROCKWOOL just remains what it is? It is what it is, and we don't need to. Yes.
I'm going to just share a slide with you if you want.
While Mahnaz is digging up that slide, all materials change their R value with temperature.
Okay.
Lucky for you guys in Canada and us here in New England, most materials go up in R value as temperature goes down. The exception to that is polyisosanuret,
right,
which has a lot to do with its blowing agents. So at the point that we hit, at least in my world, concerns, approaching 20 degrees, ROCKWOOL is something like, oh, there we go.
You can see it there.
You can see where the values cross with temperature change.
Okay, just hold on.
So basically, what happens with ROCKWOOL is that we are insulating just by being really smart in how we capture air. We're not doing anything magic. It's just stone and air. Our insulation value comes from air. And when temperatures go down, air just moves less. And so basically that's why your R value for these types of materials will go up slightly. But there is a bit of a difference. It increases because when it gets colder, there's less movement. And there are some materials such as the polyiso is, when you're doing the testing at 24 degrees Celsius, that's when you have a great value, but due to the blowing agent that is being used and its properties and its phase changing properties, it just is not as efficient when the temperatures go down.
Right, right. So,
and also, I'm sure that you've seen single ply roofs where you can see the board pattern of the foam that's underneath of the membrane. Those, and whether they're thermoset plastics or resin set plastics, they shrink quite a bit when you can see the outline of a 4x8 sheet with a fastener. So We're often used in conjunction with those materials as too. So basically insulating the insulation. You know, these hybrid roof systems are, I think, becoming more and more common as it's not, depending on what you're shooting for in our value, it's not always practical to use all stone wool. But if you allow those materials to be, to work better by staying at a higher temperature, then you kind of get the best of both worlds. If, you know, you can't have a 40-inch buildup of insulation then in cases where you're shooting for super high values on the roof.
Mm-hmm.
That's
Hybrid
awesome.
roof, yeah. And also the weight can also sometimes play a role.
Yes.
Of course, of course. Zach gave me the platform, which maybe he shouldn't have done. So I've got a third one. There is, it's just about harboring pests and just a little story. So we're
Okay.
actually applying a bunch of Rockwool to our rural residents. We have a pest problem just because of where we are, especially. And we had a weasel issue.
Mm-hmm.
A weasel that loved living under our house. So we were installing a bunch of Rockwool, and it's intending to be below grade, but it wasn't backfilled yet. And the weasel didn't mind it at all. She just pulled it away and went right through it. So I don't think she would. She wasn't mouthing it or trying to eat it or anything, but she's gone.
She destroyed
now.
it.
She destroyed it instead. Yeah. Anyway, we're happy to have that product on board. Okay, great. Thank you.
Great.
Great, thanks, Kim. Reed, you're up next.
Can you hear me?
Yes.
Yes, and very nice t-shirt, Reed.
You like that? I earned it. I worked hard for that one.
You did. Thank you for your work. Kim as well.
So as a slight disclaimer, I'm one of your distributors on the East Coast here. The EFIS boards, that's fairly new. And what's the difference between something that would accept EFIS versus comfort board or rock board?
Can I show you what was used in the Stonewool Tower?
Sure.
Basically, what you're looking for an EFIS solution is that you need to assure drainage somewhere. So if you take a standard board, it's flat, and you're not creating the extra drainage gap. I'm just going to share my screen. Why does it not do it?
So it's ribbed or dimpled or somehow.
Yeah, this is the product that was used, and not only does it, can everyone see this?
Ah, okay.
So this has on the one side, it has a mesh, so you know you can apply your finish, and on the back it's been treated like that. There are many different ways to do it, and honestly, I'm not fully up to speed as to who is making what and which is the Rockwool product or which is a product that belongs to Durock, for example. There is some development going on. Maybe Robert, you know better because there's some differences between Canada and the US.
Yeah.
But that would be I'd say the main difference between a standard board and the specific product made for this application.
Yeah, and in this case, it's kind of interesting because we're being used as a component in another system. So BASF, when they were still called that, had it labeled as their Vulcan, like, you know, volcano synergy system. And now they're, for whatever reason, called Master Builders. And the most straightforward version of it, without adding lots of bells and whistles in terms of extra layers, basically it's still mechanically attached, and it uses a really heavy bead of sealant to push the board off of the off the substrate to create that you know, whatever it is, 5 millimeter or maybe a little greater gap for drainage to occur on the substrate.
Okay, cool. I do have another question then. The comfort board, or sometimes rock board 80, on a pitched roof, do you have limitations on the pitch? It doesn't really matter.
There's no limitations on the pitch. I mean, engineering is always our limitation, right? So how many fasteners?
Physics.
Yeah, physics, it gets you every time. you know, I was actually just going through this yesterday with a project almost in Canada, in Lake Champlain in New York.
Huh.
And they want to put 11 inches of material on a variety of pitches between 4 and 8, 12. And but it also happens to be a government project where FM Global applies. And so in that case, it would need to be Top Rock, because those are the products that are tested for commercial applications, and FM Global
Right.
has gone through it with different roofing manufacturers. I believe ours is with Fabral. But in type 5 construction and in most every residential build, including what I'm doing here on my own house, you can use Comfort Board 80 or 110 and the pitch isn't really a limitation. It's just a matter of calculating the engineering for how many fasteners you need and, you know, at what frequency.
And at 10, 11 inches, if you can afford the fasteners.
Sometimes those fasteners, it's not a matter of money, it's a matter of finding them.
That too.
Before I joined Rockwool, I used a lot of stress skin panels on some of the construction around here, and those fasteners can be pretty dear, especially if you want them to be stainless steel.
Oh, geez, yes. Or 10 and 12 inches. All right, well,
Yeah,
thank you.
if I just could mention, the Top Rock product is a dual density product, which is
Yeah.
for the low sloped or the flat roofs. And by having this dual density, you don't need to add a cover board. So it gives you a little bit of an advantage there. But that is specifically for low sloped or flat roofs.
But if I put a piece of plywood on top of a low slope, I can use 80, rockboard 80.
Oh,
I
if
think so.
I mean,
I'm-
typically Rockboard is intended for inside of the WRB.
Yeah. Oh, did you?
So
I thought you
if
said comfort board.
if that piece of plywood has a membrane over top of it, then yes. But you know, it's also the case that you know, we do a lot of case-by-case analysis. So if you have questions on what the assembly looks like, or a specific application has some bearing on it as well, right? Is it commercial? Is it residential? You know, what are the local codes? You know, and things are clearly quite a bit different in Canada than they are here in the US, unfortunately.
Generally, for the outside of a building, we have comfort board and cavity rock as our exterior materials that have a specific finish. You know, we make sure that these materials have a nice surface and also have good water resistance, so we can make sure that if there's loads of rain and whatever, the load of the water actually just pearls off and doesn't even get into the insulation. So comfort board and cavity rock are those two products, and rock board actually does not have this finish or this treatment. Rockboard 80 has been developed into the Comfort Board 80, so it actually doesn't exist in the market anymore, at least not in
Right.
Canada. And then rockboard is typically or often used for example, machine and mechanical rooms on the inside, as it's just simple finish.
Yep, perfect.
Yep.
Great, thank you, Reed. So next up is Sarah Bayer, which is fun because now we've had 3 Passivhaus Accelerator presenters in a row, Kim Walton, Reed Rowlands, and now Sarah Bayer. Sarah presented last night at the Global Passivhaus Showcase about the very cool Rheingold Senior Residences, which is a Buildings of Excellence project in New York. So with that, Sarah, please ask your question.
Thank you. Yeah, my question's about embodied carbon. I think I missed whether or not you're using mostly stone and or slag, but if you're using slag, can you get it from electric arc fired furnaces? And what is your kind of position on improving the global warming potential of the product as a whole? I think some of them are a little bit higher than some EPS foam products.
So in terms of the sourcing of our slag and whether it comes from electric melters or coke melters, I'm honestly not familiar with how that goes. I have to make the wild assumption that as things progress and everybody's looking to minimize their carbon footprint, that that's the direction that things will go, but I can't speak for steel manufacturers. In terms of embodied carbon, I would say with our semi-rigid board that we sit somewhere in the middle. Best case scenario is you're able to use dense packed cellulose, right? And with our semi-rigid board, I'd say we sit just below polyiso, depending on the material. Certainly when it comes to XPS, we're head and shoulders above. But if you want to get into the weeds with that, I'd be more than happy to do that. You're in New York, I take it?
Yep.
Are you going to be in Tarrytown next week?
I wish I could make it.
Well, between myself and Todd Kimmel, we'd be more than happy to get into it. There are definitely some there's some subtleties to it, right? Depending on which carbon calculator you're using and what source data they're using. If they use the NEMA data, it's A, it's outdated, and B, we look a little better than other mineral manufacturers. But if you're using our third-party EPDs, then and then also, of course, when we look at foam and we look at mineral wools, what's happening with the total LCA, right? There is an eventual plan for us to be able to pull this material back into the supply stream, and then there's the part where we don't pump oil to make our stuff. So
yeah, well, circularity exists.
All of these are considerations.
Circularity exists in Europe for our materials because everything is more dense, everyone is closer, there are more plants, there is a possibility to actually return material, leftover material, and so on. We do we do take back material from companies that are actually converting our material that are close to our production sites, but distance is the major inhibitor of actually creating a circularity for our materials.
I realized that I forgot one part of your question too, Sarah, and that is what are we doing with our actual production? So we're moving towards, we have one electric melter thus far, and we're moving towards that in other places. We have a smaller scale one in BC that uses, generally hydropower, but depending on where our manufacturing is, if we're on a dirty grid, it's a big question mark. Are we using our Aguila technology, which uses natural gas, versus grid that comes from question mark on the sourcing. So again, I'd say it's a case by case basis on where you're located and where your material is coming from, especially if we're talking about across the pond.
Thank you. I'm happy to talk
Not
more.
the simplest of answers, I'm sorry.
Yes, it's good. Yeah, good start.
Great, thank you, Sarah. Okay, so next up we have Patricia from Rochester, who I don't see Patricia from Rochester, but I see Patricia Partridge. Same person? Great.
At the beginning, in one of the earlier projects that you showed, you talked about 2-inch foil-based boards. And I wondered about the vapor permeability or dew point, the two different questions.
So I'm not wildly familiar with that project because it was actually one that my colleague Ryan Foster worked on. But
I think he's on the call.
Is he? You better speak up. If I recall the conversation correctly, that was a requisite by the building consultant. They wanted to ensure that they weren't, to the degree that anybody's able to do a perfect job of sealing up a vapor impermeable barrier. That was the idea. If it's my decision to make with that particular application, I like smart barriers, right? So we're allowing anything that does incidentally get in there to get out, and keeping diffusion from getting into that material.
Well, I don't seem to.
Okay, this might seem like a newbie question, but I was assuming the foil face was on the interior side of the room. Okay, thank you.
Yes. And typically that material is used in curtain walls, right? Where that's the foil facing that you see on unitized curtain walls, where a backband assembly isn't in place.
Great. Thank you, Patricia. All righty. So next up is Brad. Brad, are you there? Brad Durant?
Yes, I'm here.
Great.
Again, I'm in middle of nowhere too, so I can't really show my video either.
Okay.
My question was to do with WRB. If your product is what I understand is not to be used as a WRB.
Correct.
I thought in the presentation you mentioned something about taping joints would be a WRB.
Yes, it's confusing, isn't it? We do not recommend, but we do not prohibit the taping of. It's just a question that we get oftentimes. That
I think what you might have been referring to is a Cavity Rock Black, and the tape that we're recommending is for visual purposes only, right? So you have an open joint rain screen, your boards aren't going to all fit together perfectly. You're cutting around whatever the hardware is back there. Maybe even people are using small pieces to infill. So the idea is that you can use, what are the products? We recommend 3 tapes. One's from Venture, one's from 3M, and I forget the third one. But they're just black tape to cover up the seams. That facer is just as permeable as the rest of the material, and the tape's just to keep the line of sight through the open joint rain screen from seeing any of the mineral fiber.
I see. Okay. So would typically your WRB be on the exterior of your product?
We sit outside of the water resistant barrier for continuous insulation.
And that includes the EFIS?
The EFIS is a different animal, and it's why we have that gap layer behind the material, so that that can act as a drainage layer. But without speaking too much to the chemistry behind master builders EFIS application, there's still a water resistant barrier behind our material on the substrate.
Right. So typically on a passive house, like a single family passive house kind of construction, if I'm using your product on the exterior of my wall, I am going to have to put another membrane on the outside.
No, we've got whatever your substrate is. So whether that's if it's residential, right, you're using some kind of plywood, that's where the WRB goes. Our material goes outside of that, and then really you're making a residential rain screen, so probably vertical battens, and then whatever your cladding material is.
Okay, thank you.
Great, thank you, Brad. All right, so next up we have Kyle Mcgowan.
Hi, yeah, so I was pretty much just covering the same stuff that was just talked about. In construction and I've had arguments kind of. So WRB going behind the cavity rock, and then also on top of the cavity rock, being very like tightly taped in with
Hey Kyle, your connection is making it hard for us to understand, but you did. I can read out what you wrote in the chat, which was, does the WRB get installed behind the Rockwool cavity rock on the sheathing, or would you recommend using a sheet WRB on top?
Behind the cavity rock on your substrate.
What about screw into? Can you guys hear me? Sorry.
A little bit, yeah.
Yeah. When you screw through the cavity rock into your substrate, you have air barrier, your WRB, and that's your drainage cavity. So is that susceptible to then leak? Like when you also want to create a drainage cavity on top so that it's hard to explain this when you.
I think I know what you're saying. If it's a screw through application, then it would be the higher density board, so Comfort Board 80 or Comfort Board 110. Yes, that's a concern that's raised sometimes. You know, it's a blindside penetration. We do have a pretty in-depth
document there
that was done in conjunction with RDH and actually just presented by Lauren Ricketts from RDH at the Wagdianis Building Symposium last week that looks at how that works with plywood, how that works with chipboard, and the short answer is it's a non-issue, and we actually end up in performing better with that semi-rigid mineral wool, stone wool over foam plastics. I'll drop email in the chat if you want to really get in the weeds with how all that works. We'd be more than happy to discuss it.
Can you see this screenshot here?
Yep. This
is quite a good document. It goes into the details of specifically the screw through solution where you're using a rigid board. And we've done a whole series of testing to see how it performs, particularly regarding the deflection of 3-inch of rigid insulation, 6, and we ended up with 12. We've done 3 series of tests. This is a bit of a summary, and in the last part we actually added air and water testing. So we actually have you would have to look at it in detail, but we looked at different types of insulation materials, and these are the results, whether we have leaks, whether we have moisture present, whether we have water or not. And, a vapor permeable insulation material is going to help it dry out, even when we're looking at whether there's humidity going to penetrate through that screw hole. It's helping for that. So actually, I recommend that you read this, or I'll post it in the chat, that link to this document. But it's a good point. There is obviously a penetration. The question is, how relevant is it? And our testing shows that you're actually pretty good.
Perfect. Thank you. I appreciate
share that in the chat.
Answer.
Excellent. Thank you. Okay, so next is Sasa.
Hi, it's actually Sasha. But
Sasha.
Yeah.
I should know that by now, Sasha. Thanks for being here again.
Yeah, and thank you, Zach. Well, I have a couple of questions, one of which is pretty short. And then basically, I'm just wondering, rather than taking everyone's time here and dwell into more specifics, I'm wondering who would be the best person to get in touch for the Eastern North America, or just here in Ontario, to ask a few specific questions for the product, appropriate product, and also particularly the product support on particular detailing that you mentioned, Robert, earlier.
Please, Ryan, present yourself.
Okay, Ryan's here.
Is he?
Yeah, I think he was trying to unmute himself before. I don't know where he is, but it's Ryan Foster.
Mm-hmm. Okay.
Are you there or not? Anyway, I
think there's some connection problems.
Sure. Yeah. Because I have a very peculiar project that is going to be a passive house, residential by high-end residential. So there's a bunch of questions that I want to address. So we're experimenting with a lot of, trying to use also merino wool, but also, for the interior applications. But we need mainly a product, detailing and support to choose the proper product for the exteriors. And one of the questions was also the tapered insulation. Do you have you mentioned the Top Rock DD, right? As a roofing. So what's the preference between using a Top Rock DD versus a Comfort Board 80? What would be more applicable to substitute a typical polyiso, which is normally used for the flat roofs and tapered insulation.
Our low slope flat roof solution material is the Top Rock DD Plus that comes with a bituminous coating. And that also is being converted by several companies to provide tapered materials. Yeah.
Okay, so you do provide that in Ontario. There is suppliers for that.
Yeah.
Okay.
I think the company's called Modular.
Okay.
One of them. There are a few companies that do that. Yes.
All right.
And Sasha, I put Ryan's email into the chat.
Okay. Sounds good. Thanks a lot, guys. Great presentation. Good, valuable information. And I'll be reaching out to Ryan if he's not around right now. So thanks a lot.
All right. Thanks, Sasha. Okay, so Mark Friesner, did you have a question? You have your hand raised and I put you in the queue. If you have a question, please fire away.
Yeah, so I wasn't unsure of the formatting here.
Yeah, no worries.
I'm actually visiting via telephone here. So I'm in Toronto, Canada, and we sort of, our office does a lot of retrofit stuff and additions to older housing stock. So we've got continuous insulation requirements like, you know, most of North America has right now. But my question is dealing with the older parts of the house. You know, now that we've built up the R value on those exterior or the new addition ports, we have, you know, we're using comfort board 80 traditionally on the outside, at least 1.5 inches. What am I doing on the newer or the older portions here, where I've got typically it's actual 2x4 studs, full depth studs that, you know, I'm not able to find a product for, so I'm cutting it down. If I'm trying to come close to the R value, I'm cross strapping and trying to get something else in there, but it's a lot of sort of finicky custom work. And I'm wondering if there's a better solution that you guys have out there for these sort of retrofit applications.
So I feel your pain because I live in a 250-year-old farmhouse, which because I get such a screaming deal on this material, I've been using quite a bit. And doing the same thing, right? Putting a couple inches outside and filling the dimensional balloon framed space inside. And at present, we don't have anything that's specifically tailored to that application. I would say take advantage of the RBS services in making an assessment of what's your best approach is going to be to, you know, provide the best longevity of the structure. And I've actually been leaving a gap between my interior finish and just getting the thickest material that I can in there, because you're on some level better off leaving a small gap than over compressing the material and then robbing it of R value.
Yeah, I've tried getting a product like a mortar vent and throwing it against the sheathing. It's old, you know, horizontal, typically wood sheathing, 7/8 board, and trying to get that air gap behind it and then stuffing it in. And then typically I can use a, you know, a 3.5 inch product if I use a 1/2 inch gap behind it. But then for the cross strapping, I mean, I'm wondering if I can just go straight across with a comfort board 80 instead of cross strapping, you know, what that's going to be like, you know, for boxes or whatever, or just if there's some other product that you guys have, or maybe it's a notched material that already has them in it that I can lay some kind of strapping. I don't know. I haven't seen the product there, and it's pretty time consuming on site from a labor perspective, more than just the product. So if you've got something or any sort of documentation that anyone has dealt with this, it would be really helpful. I brainstormed with Ryan Foster a couple of years ago on another project similar to this, and I keep coming up against it, and I really am having trouble finding you know, I'm not looking for off the shelf, but something a little closer would be helpful.
So are you saying that what I've been doing is, because I'm strangely 19 inches on center, 20 inches on center, so I've been taking the 3.5 inch R15 material and cutting it crosswise and stacking it up 2 feet at a time as a solution. And if you cut it and friction fit it, it generally stays where it needs to stay. if you're going from the inside up against the old sheathing. I also have other weird conditions where I can't open up the inside, so I'm doing everything from the outside and resheathing and then vapor burying, which is a whole other probably overzealous approach, but it's what I'm doing.
Are you adding a continuous element in front of that as well on the interior side, or just stuff on the existing cat?
My typical wall section looks like that balloon frame, you know, true 2x4, the 7/8 sheathing. In places where I take it off, I'm actually using conventional sheathing, putting conventional sheathing back with a continuous vapor permeable barrier, and then depending on where in the house it is, between 2 and 4 inches of continuous on the outside, and then, you know, detailing around the windows and all that stuff.
Okay. Yeah, I appreciate your help. It sounds to me like I mean, every time we open one of these up, it's a little bit different. There's no standard space. The one I'm in now, it changes. Sometimes it's 16, sometimes it's closer to 20. So it's really sort of fluctuating there. But it's more, yeah, I'm assuming I've just got to infill with whatever we've got. That seems to be it. It's more the interior is trying to get that continuous element on the face. If there was sort of anything recommendations that wise, or should I just be using as I mentioned, a comfort board 80 and just running it straight in front of the other, you know, perpendicular to the regular studs?
Oh, you mean on the inside?
On the inside, yeah.
If you have the space to spare, you could certainly look at using rockboard on the inside, because you're inside of the WRB, and depending on how intense you want to get about getting airtight, you know, you could even cover that up with Intello or something, and really go for the gold in terms of airtightness.
Mm-hmm.
There's some chat about us integrating products, interior products, with something like that, but it's chat at this point. So stay tuned.
Okay.
Nice. Thanks, Mark.
All right. Thanks, guys.
Yep. All right. John Snell, you're up next. John, I see you. It looks like you're there. Yep.
Yeah. Sorry, it took me a minute.
Yeah, no worries.
My question was about the relationship of the R value to water saturation. Is there a graph showing how the R value drops as the rock wall used below grade becomes has more water in it? I understand you need to put drainage around it, but in heavy rains, these atmospheric rivers that are coming through the west right now, the water table rises quite a bit for a short period. Is there a relationship or a graph you can pull up that shows the R value and how it changes with water?
I don't think we have anything like that. I mean, if we're looking at installing the rock board in the water table, or where we frequently have water tables rising, it's not the optimum solution, obviously, because the material dries out quickly. But if you have water constantly, you're going to have air replaced by water. So, you know, you're going to have to look at the R value of water. I'm drawing the black and white picture here, but you know, it's one thing where you're dealing with humidity of the soil, and you have your French drain and you have a good water protection, and it's another one where you have to actually waterproof and, you know, take away a high water table from around your building. That's not where I would put a rock wool.
That being said, we do have some studies on how quickly the material dries.
Yes.
So if it is an incidental high water event, and, you know, let's just say that the water table rose 2 or 3 feet in a spring melt, or you know, a torrential rain, and then went immediately back down, or back down within a matter of hours, you know, if we're talking about the material sitting on a piece of table, a chunk of the material sitting on a table draining out, it's down below 2% moisture within an hour. You know,
it does not hold water naturally. Yeah, you know, it's hydrophobic, but it's a porous material. So if you force the water in, the water is going to go, and as soon as it can go out, the water is going to go out. But then the question is, how often are you going to have the water? So as you're saying, Robert, if it, rain can fall and there might be water for a moment, but it dries. We have a whole study that we can also share here on the drying out of the material, where the material has been squeezed, well, immersed in water, and where we actually measure the water content by weighing the whole panel to see how quickly does the water leave, and as Robert says, it's down to 2% within an hour. So it remains water repellent and hydrophobic, but if you force water in it, water is going to go in it, and then as soon as it can go out, it'll go out.
Oh, thank you. The places I'm thinking about are on hillsides, where if you have a large mountain above the house, hydraulic pressure just you've built on a flat area below the hill, then just the hydraulic pressure is pushing water into the ground and keeping the water table fairly high in the winter when we get these atmospheric rivers and when you need the insulation to be high because it's cold outside. But your explanations are very helpful. Thank you.
And that's a design consideration too. What you're describing, a pitched water table, is something you want to take a hard look at before you're making that decision.
Thank you for your great presentation today.
Thank you.
Great questions, John. Thank you. Okay, next up is Stephen O'Shea.
Yes, I was wondering about the using the top rock instead of polyiso for a commercial application. So for a large roof, is that a possibility? And as far as what the thickness of that top rock would be, as far as what are the standard thicknesses, I guess?
So
it's absolutely, yeah, go ahead, Robert.
Yeah, that's very much situational. We're supported by most of the major roofing membrane manufacturers in terms of their warranty. In terms of thickness, I can look that up for you. We actually have a colleague, Joe Donnelly, who specifically deals with roofing applications, but one of the places that we're probably used the most on roofs is critical function manufacturing facilities. Think server farm, car manufacturing, places that just cannot afford to go down with even a small fire event. These are the type of projects that are acres and acres, not thousands of feet, but multiple hundreds of thousands of feet.
See here, that's ours. This is actually our plant, our head office in Milton.
Okay.
And then the other
11 inches.
Yeah. And the other one that I used in the presentation had the four-wheeler towing the cover board behind it is, I have to take a quick look, but I believe that is the Volvo plant.
I wonder whether that is tapered material here as well.
If you have specific questions, I will post Joe Donnelly's contact information, and he, along with a couple of folks on his team, are definitely the folks to talk to about the nuts and the bolts on top rock.
Okay, thank you.
Yeah.
Great, thanks, Stephen. So Joe had another question. I think that he's not here, but I'll ask it for him. It looks pretty straightforward. It's puck rock looks like it could be used under a radiant floor. How deep are the channels? Can they accept PEX tubing?
I personally don't know. Do you know by any chance, Robert?
So I'm assuming what he's saying is to flip the material upside down so the tubing would be where the concrete comes intact with it. Somebody else responded on here that they're 10 millimeters deep, but I think that's probably true.
Which is a great segue, because the next question, and right now our last question, is from that somebody, from Lowell Lowe. So Lowell, please come on camera.
Hi.
Yes.
Zach. Can you guys hear me? I hope.
Yes.
Okay,
Yes.
great. Yeah, thank you. Yes, I'm in Toronto here. I'm a sole proprietor. I do kind of smaller projects, mostly like renovations and additions. But I guess in Toronto, yeah, they have there's a program called Tower Renewal. So they're retrofitting these solid brick buildings, apartment buildings, and there's one near my office that they're doing currently. And what they're doing is they have these continuous horizontal and vertical. I took a picture of it actually, and but the channels are anchored every so often. So it's not. I guess it's not like a continuously anchored angle. So it has. I guess it allows water to drip down, and it looks like that they are using maybe semi-rigid board, because so it creates a frame where I think a cement board will be anchored onto, and then but they use this black. It looks like it's semi-permeable, if that's the right word. Is that, am I guessing that's what they're doing?
This is for a regular rain screen application?
Yeah, I think it's a rain screen. Yes.
Yeah, so if that material is going over the girts, which are over top of, however they're, whether it's semi-rigid or rigid, that could be a scrim like Reveal Shield or Delta's Facade S or SA. I forget who. Oh, Vapro. Vapro makes Reveal Shield, and there's one other one out there that I use commonly. But that's where that's why we came up with Cavity Rock Black too, because you skip that step of having to roll out the screen material and then either pin it down with hurricane washers, the big plastic guys, or in some cases folks will put it over the first layer of girts and then put black girts over top of the scrim to hold it in place while they get the cladding material on.
But that would be a WRB, would you call that that what they're doing here? Would that be considered a water? That would be a water resistant membrane, right? Is that the term?
The black facer, the scrim.
Scrim, yeah. Sorry.
I can't really speak to how much of a water barrier it is, but it's, on some level it's irrelevant, because both our semi-rigid and rigid boards are very hydrophobic. So really they act as a secondary drainage plane, and that scrim doesn't really contribute to or detract from it, whether it's integrated with our material or whether it's material from another manufacturer. It's really just there to to hide the gap between your fiber C panels or your HPL panels or whatever your open joint cladding material is.
Great, thanks. I appreciate the info.
Great, thank you, Lowell. Well, it looks like we have made it through the questions, and we are, 97 minutes into this awesome component spotlight. Mahnaz and Robert, thank you very much. This has been really fantastic. So I think unless there's any other comments, I think we're ready to wrap up today.
Thank you so much for everybody for hanging in there and all the great questions. This is the first one of these that we've done, and I can't wait to do the next one. And maybe looking forward to seeing some of you folks in Terrytown.
Definitely.
Great, all right, thank you very much. And I'm going to share, I'm just going to congratulate Robert. It's his birthday today.
Happy birthday, Robert.
Cheers, everybody.
Yeah.
Thank you.
Thanks so much. Take care.
Bye.